Hello friends and welcome to a lecture on Python. Today we will learn how to create NumPy arrays. So let's go ahead and start creating the arrays. For this, first you should import the NumPy library. So you write numpy import NumPy as np. That being done, so let's create a list. So list is a collection of elements. So we can write a list, open and close the square brackets, write 1, 2, 3, and also include a name which is dude, right? And do it. So let's check what this list contains. So it contains our elements that we have typed, and let's see what is the type of this list. So what is the data type of this list? So we type a list, and there we are done. It's a list. Now a array. So if we need to convert this into an array, we write a array is equal to np.array array, and we write the name of the list. So this is ALIST list. Okay, and there our array is created. Now let us have a look at what is the array. There we are. What is the type? This is very important. One should always check the type of the object that you have created. It's very important in understanding when you're doing programming. So let's check a, and the type is NumPy array. It's a NumPy array. Remember one thing, this is what I'm teaching you today is to create NumPy arrays. These arrays help you in a lot of mathematical operations, matrix operations especially. Now, and of course, it plays a very important role in data science. Now, is converting a list into an array the only method of creating array? Well, hell no. You can directly do it. So let's do it. array, and the first different array. So we write it as np.array, and we open and close the square brackets, and we write just 1 here. And then afterwards, what we do now, right? And let's check this. So, okay, let's print it out. That's it. So let's print it. And there we are. So it gives the one element that I have entered in the array. But the former method seems to be a bit simple, because first you can write a list and then you can convert it into an array. Now here unnecessarily, you have to first create a bracket, then second put a square bracket. You may make mistakes. So the choice is up to you. Now let's look at arrays in a much more deeper fashion. So deeper fashion, right? So we write np.array array. We start a square bracket, start and end the square bracket. And what we do is we put another square bracket in this, and we write 1, 2, and we open another square bracket and we write 3, 4, and then print, and let's execute this name. And there we have it. Now, it looks a bit different than the former one. Let's have a further look into this. So what do we do is we write dot shape and execute it. What we see is it gives an output 2, 2. What it's actually trying to say is this is an array which has 2 rows and 2 columns. The first row contains 1 and 2. The second row contains 3 and 4. The number 1 is in the first row and the first column. The number 2 is in the first row and the second column. The number 3 is in the second column, second row, first column, and number 4 is in the second row, second column. So this is the way an array is stored. This is a two-dimensional array. We can write multi-dimensional arrays. We can write arrays of dimension 3, 4, 5. A two-dimension array is a matrix. It's commonly used in mathematics, and it's commonly used in data science also to do a lot of manipulations. So now what we have is, we have an array of dimension 2 by 2, and let's create an array of dimension 3 by 3 and have a look at it. So we can write this as a underscore array array 3 dimension, and we write np dot array, and then we put a square bracket first. So we start with the square bracket, and then we again put a square bracket, and we write 1, 2, 3. Come out of the square bracket, another square bracket, 4, 5, 6, and another square bracket, and we write 7, 8, 9, and then afterwards what we do is we print this. So print, and let's print this, and let's have a look at what do we get. There, we have a 3 by 3 array. The proof of the pudding lies in eating it. So let's do Control V dot shape, shape. Let's check the shape, and it's a 3 by 3 array. So it's a 3 by 3 matrix also, it's known as in English. And now let's learn how to create arrays which, to start with, are initialized in some fashion, which we can use later on. Sometimes we require an array which has only zeros. Sometimes we require an array which has only ones. Sometimes we require an array which has random numbers. And this is required in mathematics sometimes because we wish to do some operation on random numbers or ones or zeros, and it is convenient to multiply them, divide them in, and get a different kind of array altogether. The kind of order that we want in the array, the number order, the progression of the numbers that we want in it. So let's go with the first array. So the first array that we will write is the array of zeros. So a array, and then we write zeros, zeros. So I will teach you how to write a two-dimensional array. So we write np dot zeros, and then we start the bracket and we write 2, 2, and enter, and then we write print and have a look at this. So what do we get? There. So yes, it says it cannot interpret 2 by 2 as a data type. So okay, very well. So there was a slight mistake here, and we have to put this in the square brackets. So there it is. There we put the square brackets. There we are. And there we are. So now, as you can see, this has given us 4 zeros, but these 4 zeros are floating point zeros. Okay. So if we want integers, then let's take this. And we do need to do a small change here, right? D type, that is the data type. D type is the data type. Data type is equal to int integer. So it will give you 4 zeros that are integers. See, the difference between this and this array two-dimensional matrix is that here it has a decimal point, here it does not have a decimal point. Now let us make an array of ones. So we write a underscore array array, and ones is equal to np dot ones, and then afterwards we put the square bracket, and now this time let's create a 3 by 3 matrix. So And then afterwards, let's print it off. So we print it. There it is. So, and let's execute this. There we are. Now we get a 3 by 3 array which has only ones. And mind you, these are ones which are floating point ones. So if we need a array which has integers as ones, so all we have to do is take this, paste it here, and just write the data type that you want, that is dtyp type is equal to int integers. So it will create an array of ones, but these ones are integers. As you can see, the difference between this array and this array is that we do not have a decimal in the array in the lower one. The lower array, we do not have the decimals. Now the next step is to learn how to create a matrix or an array, multi-dimensional array of random numbers. For this, let's go ahead, array, and let's do it as an array of integers. So we make an array of integers. For this, we have to write np.random.rand int. Then we write the starting number and we write the ending number. So it will take random numbers, it will create random numbers from 1 to 9. Please remember, if you put 1 and 10, it will create a random number list between 1 to 9. Now we want to give a size to it. So let's give a size. So size will give the size of the matrix that we want. So it's 3 by 3. So it will create a matrix of 3 rows and 3 columns. So let's print this off now. So print and take this, put this here and run this. There we are. It creates a random matrix, a matrix of random numbers between 1 to 9, from 1 to 9. Okay, 10 is not. Now, how many ever times I run it? You see, 1 is there, but there's no 10. Okay. What I want to also demonstrate with this is that each time you execute this command, you are going to get a different set of random numbers. Now, when you're using them in any calculation, please do not assume that whatever you have done may not change. Each time when this command is executed, a new set of numbers are created. Okay, so we need to take care of it. When we are using this ahead, we cannot assume that these numbers would remain the same. Because when we rerun the program, it's going to create a new set and we may find some, if we have derived some results out of this, it's going to be a new set of results. Okay, now let's create a random number array with float point decimals. So float numbers or decimal numbers. So for this, the command that we have is, let us say we want to create random numbers between 1 and 10, but these should be random numbers which have decimals. So for example, 1.1, 1.2, 3.57, so on and so forth. So for this, what we do is, we take the difference. Supposing we want the numbers between 0 and 10. So we take the difference. 10 minus 0 makes it 0, right? So, 10 minus 0 makes it 10. Pardon me. 10 minus 0 makes it 10. So we write 10 multiplied by random dot random underscore sample, and then afterwards we write the size of what we want. So 3, 3, and then we write plus and the starting digit. So the starting digit was 0, and let's print this and have a look. Print. So A there we are. So it says random is not defined. Oh yes, I have to put np, that is numpy. I forgot that, and there we are. As you can see now, it has created a matrix of random numbers. Now let me run this once again and show it to you. Now it has created a different set of random numbers. Once again I execute it. It's created a different set of random numbers. Now these random numbers are between 0 and 10. Okay, so between 0 and 10 these random numbers are created. Now there we are. So 0.344, slightly above 0. Okay, there we are. Now what if you want to create between 1 and 10? So the difference is going to be 9. So we write 9 here. And we write the starting number as 1. And we execute this off. There we are. Random numbers between 1 and 10. Right? So this was all about creating arrays. I have taught you how to write an array by yourself, how to create an array of random numbers, which in many cases is helpful when we are doing studies. When we are doing numerical studies, when we are studying systems, so we can create random numbers and study the effect. These random numbers can be given an input and we can see the output of our mathematical system or mathematical model that we have created. Right? So this is all about NumPy arrays, how to create NumPy arrays. Now the next lecture is going to be how to read elements in NumPy arrays. So keep watching. And yes, do like and subscribe our channel. Have a great day. Goodbye.